All right, so hi everyone. Welcome to the third and final day of the Python 101 session. And I'm excited for all of you guys to be here. And yeah, let's just get right into it. So here's some review questions that we're going to do from the beginning. So, um, what six integer and float operations did we cover last time? What's the difference between slash and two slashes? What is modulo? What's an if statement? And then what's a Boolean value and what operations help us get them?
A single slash is normal division, and double slashes are integer division.
Great.
A Boolean is a true or false statement.
Yeah. How about question one? What operations did we cover?
Less than, greater than, less than, equal to, greater than, equal to, and it is not equal to.
So those ones are the Boolean value operations, but yeah, that was one of the questions. Um, what's the other one? There's one more that you're missing. So you had not equal to, but what else is there?
I think addition operation.
Okay,
Uh,
so that's for this one. Um, actually, what I was going for is equal to. Maybe you said it, maybe I just missed that. But yeah, so the Boolean operations, like you guys said, true and false, and then we could do equal to, not equal to, less than, greater than, less than equal to, greater than equal to. Great. Did you want to continue with the first one?
subtraction,
Yeah.
uh, multiplication,
Yep.
division, uh, addition,
Yep.
Integer
uh,
division,
Yep. One more.
modulo,
modulo.
Yep. Okay. So remember that. We have addition, subtraction, multiplication, normal division, integer division, and modulo. And this normal slash is the in normal division, and the double slash is integer division. What about these two, three and four?
Modulo.
modulo is a number of reminder.
Mm-hmm. And this last one, what's an if statement? Do you guys remember? So here, let me pull up the slides for them. All right. So if you guys remember, if statements let us do logic, like a certain action if a condition is true or false, right? So if name is equal to max, and we'll print out high max, and we're using those operators, the Boolean operators that you mentioned before. So in this case, name is max, so it does print out high max. Here's some other examples. 3 is not greater than or equal to 5, so it only prints out the code outside of the if statement, not the one inside. Whereas 6 is greater than or equal to 5, so it prints out both the code that's only in the if statement and the code outside. Else statements lets us do like in this group thingy, um, like everything above is not true, then we'll do this else statement. Elif lets us add like extra conditions. So Elif name is Alex, Elif name is Giselle, etc. And then we can pair if, Elif, and else. So this kind of makes like a whole block. So all of this is one. statement, and if one of them ends, then like the whole thing kind of gets skipped. So if the name is Max, then it won't check any of these other conditions. Okay. So let's kind of look at that as well. And I want to show you that you can actually pair some operations with this as well. So value is equal to, I'm just making some operations. Yeah. So here's the first if statement we're going to look at. If value modulo 2 is equal to 0, it's going to print out this. Otherwise, it's going to print out this. Okay? So give me a number really quickly.
5.
All right. What's it going to print out?
This is odd.
And that's because,
5 modulo 2 is 1.
yeah, so it's not 0. So it moves to the next one, which is an else, which else like runs everything that gets there. So yeah, this is odd. Give me another number.
4.
And what's that going to print out?
This
Oh, what's 4 going to print out? Guys?
2.
Okay. And why do you say so?
Divided 4 with 2.
Okay. But is this division or modulo?
It's modulo.
Mm-hmm. And so does modulo return like the division or the remainder?
The remainder
Okay. So what do you think it's going to be then?
is 0.
Yeah. Right? The remainder when 4 divides 2 is 0. So what action is it going to do? Or what's it going to print out between these two options?
Even.
Yeah. Wait. So what about 0?
It's 0 again.
And what does that mean? What's it going to print out?
Even.
Yeah. So once again, explain to me what an if statement is.
If a condition is true, then a statement under it will be executed.
Yeah.
Otherwise,
Right.
the optional else statement will be executed.
Great. And then how does elif work?
There are multiple.
Mm-hmm. And then elif is optional, right?
Yes.
All right. Great. So looks like you're good with this. So let's do something a little harder. Give me a number to put in.
9.
Okay. So what is this going to print out? Okay, 9, right? What's that going to print out? Think through it. Go through the logic like one step at a time.
I don't have no idea.
All right, let's go through this one as an example. So number is 9, right? So value is 9, right? So what is value times 3?
27?
Yeah. And is that greater than 90? Or greater than
No.
No, right? So does it do this code? Does it do this action?
Uh, no.
Okay, so where does it go to now? Which step does it go to?
The next one.
Which is? It's
Answer B, maybe.
no, this one, right? Elif value slash slash 2 is less than or equal to 5, right?
Yeah.
So what is 9 integer division 2?
4.
Okay. And is that less than or equal to 5?
Yeah.
So this condition is what? True or false?
True.
Okay.
True.
So does this code run?
Yes.
It-
Okay. Now, will any of this code be looked at? Like, will it get to any of this code? Will it consider any of these?
No.
No, right? This was true, so it just like ends the if statement there. This whole if statement, it starts with an if and ends with an else, right? The only time you can start a new one is by putting a new if. This whole thing, if the first one is correct, then it would literally like skip all of this. Okay, but yeah, you guys were correct. Answer B. Give me another number.
10.
10? Okay. And so what output is going to be? Which answer is it going to print out?
C.
Answer C?
Yeah,
And why is that?
because 10 plus 5 is less than 16.
So it's gonna print out C.
Sorry.
It's all right. Let's work through it one at a time, right? Try going through step by step.
B,
B. Okay, do you want to explain your logic, how you got there?
because 10 integer division 2 is 5.
Okay. So that makes this condition true. But does it just automatically get to this condition, or did it have to look at above ones too?
It had to look at above ones.
Okay, so when we're explaining, we have to show that this is true and all of the above ones are false. So why is this false?
Because 10 times 3 is 30.
And that's less than 90. Great. See it? Okay, how about 21?
Answer C.
Okay. And why do you think so?
Because 21 plus 5 is 26. So it's greater than 16.
Great. So we show that this is true, but we also have to show that everything above is false, right? So why are all of these false? Because remember, the code goes one step at a time. It can't just automatically skip to answer C. It has to check this, then this, or it has to check this, then it checks this one, then it checks this one, and if this one is finally true, then it prints out answer C. So why is this wrong and why is this false?
Answer A.
Because
Because
21
1
times 3
times
is
3
63,
is
and that's
63.
less than 90. And 21 integer division 2 is 10, and which is greater than 5. And 21 plus 5 is greater than 16.
Great. So it stops here and prints out answer C. Can you guys solve this one?
Answer C.
And why is that?
Because
Answer A.
31 plus 5, it is 36. So it is greater than
Answer A,
60.
because 31 times 3 is 93.
And that's greater than 90, right? Okay. So just remember, it goes one step at a time. So we can't just skip to answer like this operation. We have to check the first one, then the second one, then the third one. And then if all of those are false, only then we move on to the else and just like there's nothing to check there. Else is automatically true. So yeah, answer A. Okay, let's try that again with hmm, 290. Retta, I want you to answer this one.
Answer A.
Okay,
Because uh, 90 times 3 is 270, and it's greater than 90.
great. And then let's do one more before I ask you a bit more of a difficult question. Um, what do you guys think for 17?
C. Because uh, 17 plus 5 is 22 and
Mm-hmm.
is greater than 16.
Okay,
And A is not correct because 17 times 3 is 51. so it's not greater than 90.
Okay. There's one more between them, right? We gotta check A and B. So we're to why is B
Uh,
not? Yeah.
the B, the modulo will be 1, and and it's less than and equal to 5. So B is true.
Is this modulo?
I think so.
No, 17 integer division 2 is 8.
Yeah, so this one's integer
So it's
division.
greater than 5.
So yeah, this one's integer division. So that's one where it's like it does normal division and it cuts off the decimal if the two number yeah, if the two numbers are integers. Right, I'll show you an example in a sec. Um, not modulo. So modulo, remember, looks like the percent sign. So 17 modulo 2. You are correct. That is 1. I don't know why this is going so slow. There we go. But if we do 17 slash 2, like that's just normal division, right? 17 divided by 2 is 8.5. If I put another slash, it cuts off that 0.5 and you get 8. Does that make sense?
Yeah, pretty much.
Okay. So now I want to ask you this. We've got an answer A, we've got an answer B, and we've got an answer C. What number do I have to put in to get answer D? Yeah, so I'm going to change it to that. You guys figure it out?
Number 10. Uh,
Correct. Do you want to explain how you got there?
yes. Because 10 times 3 is 30, so it's not greater than 90.
Okay.
Then it got elif B, uh, integer division by 10 by 2 is 5. So 5 is not less than 5, it's equal to.
Hmm.
And C, 10 plus 5 is 15, and it's not greater than 16. So I guess it's 10.
Great. Is there another number? There's another
Probably.
integer. Okay. I'm going to work through this a little bit more methodically here. So this is asking if a number times 3 is greater than or equal to 90. If you guys remember in math, if we divide both sides by 3, right, I can get rid of this, and this becomes 30. So now this is just saying if value is greater than or equal to 30, then it's answer A, right? Because 30 times 3 is 90. So anything 30 or above will result in that. I'm going to skip this next one for a little bit. Well, value plus 5 is greater than 16. So that means if value is greater than 11, we subtract 5 from both sides, right? Because 11 plus 5 is 16. So any number that's greater than 11 will have a value greater than 16. So that works. And this one right here, normally you just multiply by 2 and get like value is less than 10. But because it's integer division, remember that 11 integer division 2 is also 5. So actually this is saying that value is um yeah, it is that value is less than 10. Sorry. But you also consider 11 is also included. But yeah. So we need to find a number that's not greater than 30, that's less than 10, that's not less than 10, and is not greater than 11. And so you're correct. 10 is one of those, and the other one is 11. So answer D is also from 11. Okay. I think you're getting the hang of this now. So let's move on. Actually, right before we move on, do you guys have any more questions with if statements, or does anything not make sense to you about them? All right, so looks like no, but feel free to stop me anytime if you do have any questions. And if I'm going too fast or you don't understand anything, just unmute and tell me, and I'll go over it again or go slower. All right, so let's look at loops now. So loops basically allow you to repeat a block of code multiple times. Okay? So you can think of it like if you're running a lap or something, or like running a race, right? You're gonna repeat that lap multiple times. Like I'll go first lap, second lap, third lap, fourth lap. That's I'm looping through, right? Same way that track might be called like a track loop, something like that. And there's two main types of loops, for loop and while loop, but we'll only be looking at for loop because while loop is like a for loop but harder, and generally you just use a for loop. So here's how it would work, like with the flowchart. And loops use conditionals as well to build up their logic, right? When you're running through, it's like if I want to do 4 laps around the track, I'm going to say, is lap 1 done? Or is lap 4 done? If no, then I'm going to go through and do another lap and check again. And if lap 4 is done, then I'm going to stop. So is the last item reached, right? In that case, like the 4th lap. If false, it's going to do some action. In that case, is run another lap. Otherwise, and then it's going to go back and check again. Keeps on checking till it's true and then exits. So you can see kind of some if statements are popping up here. Yeah, so for loops let us repeat an action and they're kind of like steps on an assembly line, right? So each step it goes 1, 2, 3, 4 till it's done, and then it like packages the and ships the item. Okay. So here's what the syntax of a for loop looks like, and it's kind of weird looking, but let's break it down. For is your Python keyword. So you guys remember how an if, like it had if to tell us that we're starting an if statement? In this case, we put for to tell Python that we're starting a for loop. Then we have iterator name. So the iterator is like something that represents your current state in the loop. Okay? So when we're running those laps around a track, that's like your current lap number, right? And this is just going to be some variable. You choose the name. Variable names apply. Variable rules apply. But generally, people just do I because I is for iterator. So, like I is your number of laps, like your current lap, right? You're on your first lap, then you're on your second lap, then you're on your third lap. And that value changes throughout the loop. In is another Python keyword, and that's just used with for loops to like kind of tell you what you're looping through. And the thing you loop through, so it can either be a list of items, which we're not going to cover today, but you guys can learn more about that on the Python 101 course on Robotics Academy. but it's just going to be something that's going to loop through, or something is supposed to loop through. So in that case, it's like laps around a track. That's what you're looping through. Then you have that colon again, and then a tab, right, to show that this action is in the loop, and it has an action. So it's actually very similar to how if statements looked. Okay. And I think you guys will understand a little better when we start writing them in code. So here's an example. For tells us that we want to start a loop. We name the iterator I, and then it's in, so I want to do it in the range from 0 to 5. Okay. So range basically tells us that you want to iterate from the number 0 to the number right before 5. So the number right before 5 is 4. And each time we're going to print out I, whatever the current state of the iterator is. So if I'm trying to run like laps, then when I first get to a track, I haven't ran anything, so it's currently at 0. So I'm gonna run a lap, and then I'm gonna say what's my new lap value. So now it's 1. Then I run again 2. Then I run again 3. Then it's 4. So I run. And that's kind of what it looks like. Let's break down how this range thing actually works. So a range, you're gonna have range and then parentheses, kind of like how we had the print statement. And then there's just 3 values that you have to put, but 2 of them are optional. So start is the number what to start at, and default it's 0. You don't have to put this in, okay? So if I and then stop is the number to stop at, which is required. And it doesn't actually stop at that stop value like you can see here. It didn't actually stop at 5. It stopped at the value right before it reached 5, right? Like say you wanna like go to a house, right? Like when you have directions, right? It's not gonna tell you to like go through the house or go into the house, like drive the car into the house, because now the house is destroyed. Instead, it's gonna take you right up to the house, like right before the house. Kind of like how that stop value is working. And then there's a step, which is saying how much to increase the iterator each time. So in this case, what is the increase in the iterator? What's the step value here?
1.
And why is that?
Because every loop is increasing by 1.
Yeah. 0 to 1 is increased by 1. 1 to 2 is increased by 1, and so on. So in default is 1, and it's optional. So you can see that if we did 4 plus 1 again, then we'd hit 5, and we would stop. Or, like, we wouldn't get there. So really what it's doing is, like, each time, it starts off with the first value, 0, and it checks is I less than 5. Okay? Uses less than, not less than or equal to. If if it's true, then it runs this. Runs like the first action, keeps on going. Once we get to 4, it's like, okay, so now we're 5. Let's check before that we should keep on going. Is 5 less than 5? False. And it breaks the for loop. Hope that made sense. And you can see that the step is optional because there's no step value, right? It goes start, stop, step. And actually, we could just remove this like 0 as well and just put range parentheses 5, and it would work the same because 0 is the default value and it's optional. Right? So range of 10 would look at like it would go through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts at 0, the default. And step of 1. This one 5 to 10 starts at 5, ends at 9, right? Increment of 1. The start changed though. And still, we stop right before we hit that 10. Let's look at 212 with the new step value. So this goes 2, 4, 6, 8. So it's going up by 2 each time. And it stops at 10 because if we add 2 to 10, then it's going to be equal to 12, not less than 12. So it ends it. Did that make sense so far?
Yeah.
Yeah.
Okay. So what is this going to print out?
15 up to 19.
Right. Also, if you want to make the step value, if you want to put a step value in, you have to put the start value. So it's like there's three different ways you can write it. You can do like range of just stop. You could do range of start stop, or you could do range of start stop step. Right? You can't do stop and step. You can't just do both of those. It's a little weird, but okay. What is this gonna print out?
18. 0 up to 18.
Okay. 0, 3, 6, 9, 12, 15, 18. Remember to say that it's like 0, 3, 6, 9. It's like in values of 3. But yeah, that's correct. How about this? Or actually, this?
0, 3, 6, 9, and 12.
Sorry, I just changed it to different step.
0, 4, 8, 12.
Yep. Let's see. What else can we do? This one's a bit tricky. How about this one?
Invalidity intax.
Sorry?
Invalidity. Invalidity syntax.
Hmm. This just prints out 12. Because it starts at 12. Is 12 less than 14? Yep. Let's do this action. So it prints out I, which is 12. Let's go again. Let's add 4. So now it's 16. Is 16 less than 14? No. So we break it. How about this?
Nothing.
And why is that?
Because 5 is not less than 5.
Right. So it just breaks in the instantly. Nothing's printed out. And something simple. What's that gonna cause? What's that gonna print out?
0, 1, 2, 3, 4.
Great. Okay, so you guys understand loops, right? Okay, so just to make sure you guys know how to code them as well, I want you to in chat write a loop that goes from and actually I want to show this really quickly. The action does not just have to be printing out I, right? You could say like x is equal to an input value, and it's gonna print out hello x. If I set it to 3 times, it will do this 3 times, right? That's another thing. If I just have this 0, 1, 2, that's 3 times. So I'll do this 3 times. It will ask me what's my name. So Manvik. I do I could do right. So it does that 3 times. Things like that. So I just want to make sure that like you guys don't think that I have to use I and I have to just print it out. Right. Okay. But for this exercise, I want you guys to make a loop that what's it called? Let's have it print out 0, 5, 10, 15. So what's the code for that going to look like? Yeah, so I'll give you about a minute to Write that in chat.
Zero, comma 20, comma 5. The range is 5. I
Okay,
mean the state
but what's the code gonna look like? Can you type that in the chat? Like the full for loop.
for I.
Or type it, don't just say it. And remember, I want the colon and then the tab and the print I as well. Just want this as well. And here's the output. That's what I want to see. Okay, that's good from Sue. And then we have a little bit different from Etta. Okay, so I'm gonna try both of them. So, and if you want to know how you could enter, like in Zoom, you could do like hello, and then you could if you hold shift and you hit enter, you can go to a new line. Or if you copy paste directly from Colab, then it will automatically make the new line like that. Okay, but so let's go see what we did first. 525. It's gonna print I. So that actually starts at 5 and then goes 5, 10, 15. So it gets this bottom half, but it misses a 0. So actually would start at 0 for this one. Okay. Let's do one more. So this time I want it to print out. Let's do it like this. It's gonna start at 2, end at 7, and increment of 3. Or sorry, end at 30, right? But I want it to give an output of 7, 10, 13, 16, 19, 22, 25, 28, 30. Right, and you can see that this automatically like doesn't give that output. 34 small. Okay. So I want you to use this range, right? You can't change the range, but you can change everything else. Uh, and I want you to get this output instead of this. How do you think you can do that? Okay, so that would result in the correct code, but I don't want to change the range. The range has to be this. You can change everything else, but you can't change the range. Okay. So what do you think as well? Okay, so we are a little slow on time, so I'm just gonna give it. So it would be I plus 5, because that, like you can see, the normal I is always going to be like 5 less, and since we can't change the range, let's just change the I we're printing out. So yeah, 7, 10, all the way to whatever values we wanted. Okay, great. So you guys look like you know your loops now, so let's get on with it. All right, so here's another example. The range 0, 5, 2 gives you 0, 2, 4. So spot the error here. This one's might be a little tricky for you guys.
Total is not defined.
Okay, yeah. So if we try and run this, which I'm gonna do, what this looks like is we're trying to make a value total that's like the sum of all these i's, right? But when we actually run this, it says total is not defined. And that's because the variable, we never really defined it. So the way we define a variable, if you remember, is like this equals thing. The way we initialize it. So we're initializing it and we use its value. So Python's going to be like, okay, so I don't see a total before, so maybe they're initializing it. So yeah, let's set it equal to total. Let's see where total was defined in a previous one, and it's not been defined. And Python gets confused and tells you what is going on. Total is not defined. So the way we'd actually like fix that is define it to something. Let's define it to 0, and now it prints out the sum. Great. So let's go into import. So importing things uses like this thing called import, and then you write the name of a package or library. So these let you use pre-written code for certain tasks. So the time library lets you use like timers, right? What's the current time? Wait 5 seconds and then run the next code. Stuff you can't normally do in Python. Random lets you um, get random values. Tkinter lets you make like apps and stuff. So that tic-tac-toe we looked at 2 days ago, that was made with Tkinter. And Turtle, what we're going to look at today, lets you draw cool patterns. And sometimes these packages aren't already installed, so you have to install them. And the way you use that is with pip. So it's Python's package manager. And Google Colab, that looks like this. You put an exclamation point to tell Python you want to install something or do something with pip, basically. Then you write pip install in the name of the package. So, like I said, the Turtle module is a built-in Python library for drawing and graphics. And it lets us have like a simple way of saying shapes, patterns, animations, and just cool things. And it's really good because then you can learn how to program visually. Like you're seeing your code happen. It's not just printing out random numbers. So first we need to install the module. So I did say it's inbuilt, but it doesn't work with Google Colab. So we have to get this thing called Colab Turtle Plus by installing it. So this is what it's going to look like. pip3 install Colab Turtle Plus. And make sure you type this exactly or it will not work. And what this does is it installs the special one that works for Colab. So let's go to our notebook and type this code in. Okay? Put it in chat so you can copy paste. Okay, so we're gonna do that one exactly. Right? And let me know once you've done that. Oh, and any questions about loops or imports and stuff like that? And once again, once you copy paste that, do that. But we'll try and get a little bit into Turtle, so maybe a little bit over, just so you guys can get some cool drawings going and you can mess around with it on your own time. And Python is a lot to learn. There's always new things to learn. I'm not even done learning it yet, especially with these packages. So, um, if you guys are interested in learning more, like I said, there's a course on the Robotics Academy, and we can keep on doing further Python sessions in the future that go more in depth, right? Like looking at lists or looking at more cool operations. Um, but that's something that you'd have to contact us, so you can send an email to if that's something you're interested in, like talking about. We would need like around 10 students though. But yeah. So have we installed it or have we put the install command in? Can I get like a yes or a no?
Yes.
All right.
Yes.
And then do we have any questions about any of the stuff so far? Any questions at all?
So,
Why we need libraries in Python?
Okay, great question. So let's look at some of the example libraries. Time, random, and Tcon, and turtle. So turns out, like actually writing, so some of these you literally like can't do it with base Python. Or like actually writing the code to do that is really difficult and really hard, and no one wants to do that. So these libraries make it so that writing like tons and tons of code, like 100 lines of code or something, can get condensed down to one little simple thing, right? So instead of saying like writing some like weird complex code to make it pause for 5 seconds, you can say time dot sleep 5. Did that answer your question?
Yeah.
All right. So we got that installed. Oh, and do you have any more questions?
No.
Got that installed.
no.
And now we're gonna import it, right? So this is how we're like bringing this code into Python. So we installed it, we have to say that I want to use this in my code. So you have to import all the code. And really what's happening is like you're taking all of their code and you're copy pasting it in and saying now I can use it. So the code we're going to use is import Colab turtle plus dot turtle as my drawing tool. Do that exactly, otherwise it won't work. And once you're done, you're going to run this code. It's going to like give you some stuff like that. Or here, it's going to look like this. Right, something like this. And give me a yes or no when you're done with that.
I'm done.
I'm done.
Great. So to tell Python that we want to start using turtle, we have to use this command, which is dot initialize turtle. Okay, this is another command you do have to be very careful with. So we're gonna put that in another code block. So you're gonna do plus code and put that in. And if you were to run that, you'll see this screen come up, which is like the turtle's drawing environment, right? So tell me when you're done with that. And if a screen pops up, then that's great. Or tell me that a screen pops up. Okay, if you guys just unmute and let me know what happens when you run it. So were you guys able to get the screen up?
Yeah.
All right. So you can also change the speed of the turtle. It's like by saying my drawing tool dot speed, right? So this is gonna be like a speed variable, and we can set it to like 1 to 10, where 10 is the fastest, 1 is the slowest. So for me, I'm gonna do something in the middle. I'm gonna say around 5, but if you want to do slower or faster, you can change that value. Okay? If you run that, nothing is really gonna happen, right? You can also change things like the size of the turtle or the size of the pen and the color. So for color, you can either like just write the color name or you could say like RGB. So you're gonna do like pen size of 3 and a pen color of blue. And I'll send all of this. Oh, I'll send this all in chat if you want to add it. And I do urge you to like mess around, see what happens if I do like orange, red, blue, things like that. And that code was wrong, sorry. Now if we run it, you should see a turtle pop up in our color. It's not actually a turtle, it's an arrow, but it's close enough. If I do orange, it turns orange. If I do purple, it turns purple. But I'm gonna do blue for now. Okay? And then here's how we move it around. So it's really simple. We put the name of our turtle, so my drawing tool. Then we tell it like a dot, and then the direction. So like forward, backward, right, right, or left. So forward and backward work by moving forward like 100 steps or backwards 50 steps. The step size, like the length of a step, is called a pixel, right? So my drawing tool dot forward 100. Let's see what that does. And you'll see that it moves forward about 100 pixels. You can see it made a little line as well. You can also turn the turtle around with like right and left. So this is a 9, and it does the angle. It rotates in that angle, so 90-degree turn or 45 degrees left. So we can see what dot right 90 does. So now it's going to go forward and turn 90 degrees to the right. Did that make sense to you, everyone?
Yeah.
So using this code, did you guys were you guys able to make like a turtle move around?
Yeah.
Okay. So quick challenge. Can you make it move in like or draw a square where each of the side lengths are 200 pixels? What's that code gonna look like? Or how about this? Can you guys help me write the code? How do I write the code to make a square with a side length of 200 pixels? Remember what like angle each angle of the square is as well. That might help. So if we're a little confused, so I'll go over it. So first thing is I want the length to be 200, right? So that means I'm gonna make it 200. Now a square has so one like forward draws one line, right? And a square has how many lines or how many sides? Four sides, right? So and I'm gonna need to do this four times. So each time I make the turtle go forward, right? I need to make another line that is 90 degrees to the other one, right? So it needs to rotate. So it's currently facing up, and I need it to face. And so the side is like this, is this. This angle is 90 degrees. It's currently facing up. So it needs to rotate 90 degrees. And then it's like the right direction. So I'm going to make it go right. And it's going to do that motion every single time it makes a side. So it's going to make it do it four times. It's going to do this motion four times. So just going to make it four times. And now when I run it, one, two, three, and four. So it just made a square. Now, doing this four times, can you guys think of a faster way of writing this? like a simpler way of writing this based on the maybe some topics we learned today? You can just unmute it and say an answer.
Loop.
Great.
There's a loop.
So what's the code with the loop going to look like? So maybe I guide you guys through it a little bit. So I want to repeat it 4 times, and I want to repeat this action 4 times. So I need 4, I in range, and how many times? I need 4. So I doesn't actually matter. I just want to make sure times are correct. So 4 is going to go what? Like 0, 1, 2, 3. That's 4 times. So that's good. I want to do this. And I tab this over because I want that to be the action in the loop. So let's run this. And yep, that worked out great. So that's kind of how you can incorporate loops into making these shapes. So here's another example. This one has a side length of 100. And say we wanted to make a rectangle, right, with 250 or 200 and 100, right? I couldn't really loop through because I didn't want to do the same action each time. But I know I'd want to go 200 and then, or let's see, let's just draw it from scratch, right? My drawing tool, dot forward, 200, and then I know I want to rotate 90 degrees again because 90 degrees for a rectangle. Okay, so I kind of want to do the same, but now it's going to be 100 as a side length. So it's going to go like long, then it's going to go short, then, well, opposite sides of a rectangle have the same side length, so it's going to be this one again. And then again, opposite sides, so it's this one. Now if I try this, yep, that's a rectangle. And what I notice here is that I can't loop 4 times, even though there's 4 sides. But every 2 sides, I do the same thing, right? I draw 2 sides and I do the same thing. I could probably loop that for, so there's how many sides? There's 4 sides, and every 2 sides, I do the same thing. 4 divided by 2, I have to loop it 2 times. So now if I loop it 2 times and draw 2 sides the same way 2 times, I get a rectangle. Great. Did that make sense to everyone?
Yeah.
Great.
Yeah.
And then I can also make a circle. And the way that works is I write dot circle, and the radius of the circle is going to be what value I put in. So let's do a radius of 100. Now when I draw it, it's a pretty big circle of radius 100. Right, so if I measure from the center to the side, it'll be 100. Okay, that's pretty simple. Now if I wanted to make something like a triangle, then what do you guys think a triangle would look like? An equilateral triangle. What would the code for that look like? Remember that an equilateral triangle has inside angles of 60 degrees. So tell me what that's going to look like. You can unmute and like tell me what to write. Okay. Guess I'll uh, guide you guys through it a little bit. So we're gonna go forward, right? Like we first have to make a line. Let's do 100. Should be simple. Well, I didn't know from the get-go that equilateral triangle has like three equal sides. So I'll probably have to do the same thing three times. So I'm just gonna make a loop. And three sides, so I'm gonna loop it three times. So let's be tabbed. And then each angle, what's the angle of an equilateral triangle? Well, the angle is 60 degrees. So I'll make it turn right 60 degrees. Huh? What just happened? Does that look like a triangle to you guys?
No.
No.
So what went wrong?
Uh, the angle should be 20, 100, I mean.
Okay, I'm gonna try that. Oh yeah, so that worked. But why? Why did 120 fix it? Just gonna do it left for now so it draws a little higher. Why did changing it to 120 make it do a triangle instead of like why did 60 not work? Do you guys know the reason behind it?
I think it measures the outside angles.
Yeah, that's kind of it. So it's like a middle between. It's not necessarily the full outside angle, but like think of it like this. So the shape has 60 degrees, like in the inside. The turtle is facing like this way. So you can see it's like kind of like a line. So this is 60 degrees and the whole thing is like 180, right? So the other angle is going to be about 180. Actually, let me see if I can kind of draw it. All right, so I saw the turtle in blue, right? It's a little off center, but and then the thing here. So this is 60 degrees. And by geometry, we know that this is 60, so this is 120, right? Now, the turtle, right now it's facing this way, okay? And we know that like the rotation rotates like the turtle. So if I want to turn it right, it'll rotate it this way. So what we're actually doing is if we just rotate it 60, then it will rotate like to about here, right? I'm gonna do like in red, like the potential rotation. Route that way, where this is 60 degrees. But actually we want it to rotate 60 degrees like inward. So in that case, we actually want to rotate this full 120, and that gets it to point this way. So, bit of a formula for that is if you're making a shape, you're gonna do the turtle is gonna rotate 180 minus the inside angle. So like a hexagon, if I want to do hexagon has six sides, and if I wanted to make that, that's gonna be 180 minus the inside angle. Inside of angle of a hexagon is 120. So 120, okay. 180 minus 120, 60. And if we have six sides and 60-degree turtle rotation, we make a hexagon. Does that make sense?
Yeah.
All right.
Yeah.
Okay. Another thing you guys can do is like we change the color of the pen. We can also fill it. So in the very top, like we have to sell it. I want to do my drawing tool dot fill color. Um, so let's do green. All right, actually, so green. And when I do begin fill, so this tells us what color I want to fill with. If I do begin fill and then I do end fill, this tells me that whatever shapes I create in this time, I'm going to fill it with color. So now if I run this, it's going to draw the hexagon and fills it with green. If I make the pen size like 10, you'll see a thicker pen a little bit. It's only a little bit thicker. Maybe if I do 100. Okay, so that's a bit more thick. But you can see that's how you can fill things with color. You can also make cool patterns with loops. So instead of doing shapes like precisely, you can get things like a spiral pattern with the loops. I'm going to remove these fills. So let's see. So there's 4i in range, 36. And these are all just examples of how you can use to make like cooler drawings, like their drawing techniques. Okay. So now when I do this one, well, actually this goes kind of slow, so I'm gonna speed it up. All right, you can see I can use the speed and things. I'm gonna just rerun the code. It's bugging out a little bit. Okay, but you can kind of see it's making a spiral, but a little weirdly. All right, so those are some of the, and the reason it's kind of working weirdly is because it's Colab Turtle. It's not the real turtle. Uh, then another thing you can do is you can use hide turtle and show turtle. So if I hide the turtle, it will, like the arrow will disappear, but it'll still move around. And I can show the turtle by doing it at the end. So now in this case, it's going to do this. You don't see any arrow. And boom. When it's done, it shows the turtle again. Okay. Any questions about that? About these turtle like color and things? Can you just unmute and ask me? So any questions, guys? Okay, so it looks like there's none. So let's just finish up. So what command is used to move the turtle forward? If you want to just unmute and answer. So looks like we're a little tired by now, but all right. So I'm just gonna give some closing remarks and then we can end that. So on the Robotics Academy course page, we have some great uh, courses and things like that. So uh, yeah, be sure to check that out. There's some projects you can use to build more Python skills and things like that. And there's a lot to learn with Python, like I said. And if you're interested in doing more sessions, then please contact us and let us know like when you'd be available to do those. Uh, and we'd love to teach more Python. But yeah, so be sure to check out the course to do some quizzes, practice assignments, practice projects, things like that. Uh, and if you want to mess around with Turtle more and you happen to create a really cool design, then so Python 101's place to go to check those out. But also email us with any cool designs that you happen to come up with Turtle. Just email us the code or like a picture of the design, and we'd love to see it. But yeah, thank you. And so before we go, I did want to just share this form. So I want you guys to fill out this form really quickly before we leave, just so we could get feedback on the session and what you guys liked, what you guys wanted to see improved, things like that. And also, if you have any questions about any of the Python that we've done so far, please ask me now. And you can just come off mute and answer. Okay, so it looks like no questions, which is great. But if you do have more, email us, check out the course, and things like that. Were you guys all able to get the feedback form?
Yeah, we were.
All right, so be sure to fill that out. And once you're done filling that out, you're free to leave the meeting, or if you have any questions, feel free to stick around. But yeah, thank you guys so much for showing up to Python 101, and we hope you enjoyed. We hope you learned a lot, and we hope you're interested in learning more in the future. Yeah, thank you guys for coming.
Thank you for today's lesson,
Yeah,
and it was very interesting. Thanks,
that's great
bye.
to hear.
Thank you for teaching us Python 101.
Yeah, you're welcome, guys. And if you guys want to learn more Python, like I said, the course, or email us, and we'd be happy to set up some more sessions.